Hello everyone, today we gonna try to resolve this question. This question is from Euclid contest. This contest run by University of Waterloo. It's for grade 12 and more advanced contest. So Euclid contest is mostly to see your ability to prove problems, not just solve and find numerical answer, but to find proof for questions. Okay, let's start. So what we have here. So let's write those. So let's write those products, right? So it will be. Let's write those products. So it will be n times 2n, then 2 times 2n minus 1, then 3 2n minus 2. So following this logic, it will be k 2n minus k plus 1, and then p 2n minus p plus 1, and the last will be n times n plus 1. Okay, and p and k are both less or equal to n. Okay, so now let's assume that these terms are equal, right? So, and we can equate them. So it will be k 2n minus k plus 1 equals to p 2n minus p plus 1. And remember, we assumed that p and k are both less or equal to n. Right, so next step, we're going to open brackets, and k minus k squared plus k equals to 2np minus p squared plus p. So we're going to take everything to one side. So we have p squared minus k squared plus 2nk minus 2np plus k minus p equals to 0. Then p minus k, p plus k. Here we have 2n k minus p plus k minus p equals to 0. Okay. Then we have common factor p minus k, right? So in the second and third term we have k minus p. So we're gonna change this plus and this plus to minus. P minus k, we have p plus k minus 2n minus 1 equals to 0. And then we have p minus k, p plus k minus 2n minus 1 equals to 0. So for this expression to be equal to 0, one of the terms must be equal to 0. But we know that p plus k minus 2n minus 1 is not equals to 0, right? That's not equal to 0 because we assumed that p and k both less or equal to n, right? So even if let's assume that let's say they equal to n, p and k both equal to n, then we have 2n minus 2n minus 1, so it's not 0. So it means that p minus k must be equal to 0, but it follows from here that p equals to k, and it means that these two terms must be the same terms, equal terms. Okay, so and it proves our hypothesis, right? So it proves that there is no such n that two products are equal. Okay. Please don't forget to subscribe, and I'll post more questions. And as I said before, some of those questions are easy, some of those questions are hard, challenging, but always interesting. See you around.